Okay, we're going to find the area of quadrilaterals and triangles. This is from section 9.1 in your textbook. And it is area of triangles and quadrilaterals. Area of triangles and quadrilaterals. So we've done area of triangles before in previous classes. And you've even done some quadrilaterals. You've done area of square and rectangle. And so some of this will be familiar to you. Let's see. Let's try our first example. Example 1. Let's find the area of this parallelogram here. Let's say that let's use this to indicate height. And remember that the height needs to be perpendicular to the base. So the height, which is here, this height here, that needs to be perpendicular to the base, and this symbol means perpendicular. Okay, let's say that we have a height of 4 inches and a base of 6 inches. Now, it doesn't matter if this 6 inches is here or here. Those are both the bases. But this 4 inches, that can't be here. That's not the height because it's not perpendicular to the base here. Oops, I shouldn't move that. It's not perpendicular to this base. This is not the height. All right, so let's look at our formula for the area of a parallelogram. And I can put this little symbol down here if you remember when we did parallelograms. So area of a parallelogram is base times height, just like a rectangle. So in this case, the area of this parallelogram will equal base 6 inches times height 4 inches. So then my area equals 6 times 4 is 24, and inches times inches is inches squared. And when you find area, the units should be squared. All right, let's try one where, let's call this example 2. Let's try one where we have the area. Let's say we want to find the base of a parallelogram. So I'll draw my parallelogram here. And let's say we have the area. The area is 56 yards squared. And we have the height. The height is 7 yards. But we don't know the base. We don't have the base. So I'll do the same thing as before. I start out writing a formula for the area of a parallelogram. And then I'll fill in what I have. I have area, so I'll fill in area. 56 yards squared. And I have the height, but I don't have the base. So let's leave the base B. Let's put in our height 7. We'll leave the units of measurements out for now just to simplify things. Now I want to, oops, that should be multiply. So I want to solve for B, so I'm going to divide both sides by 7. So B equals 56 divided by 7, which is 8. And in this case, it will be yards. All right. Let's try triangles now. So let's do the area of a triangle. This will be example 3. And let's say I have a triangle like this one. Happens to be a right triangle. And I have one leg of that right triangle is 12 meters. The hypotenuse is 20 meters. And let's say I don't know the base of the triangle. I need the base of that triangle. So let's remind ourselves of the formula for the area of a triangle. Area of a triangle equals 1/2 base times height. And so I need that base. I don't have it. So let's find the base. It's a right triangle, so I can use Pythagorean theorem. So I'll say a squared, which will be my 12 squared, plus b squared, I don't have that, equals hypotenuse squared, or c squared, which is 20 squared. 12 squared is 144, and 20 squared is 400. Now if I subtract 144 from both sides, then b squared equals 400 minus 144, or 256. And then if I take the square root of both sides, I'm going to get b equals plus or minus 16, but I'm just going to use the positive 16 because this is the length of a side of a triangle, so it can't be negative. So I'll put my 16 in there. So now I have my base and my height, and I'm ready to plug that in to my formula. Area equals 1/2 base, 16 meters, times height, 12 meters. 1/2 of 16 meters is 8 meters. And 8 times 12 is 96. And meters times meters is meters squared. And so there's my area of my triangle. Let's try one like we did last time. Let's do example 4. And let's say that we have let's say this one's a right triangle also. Let's say that we have the height of this. Let's say the height is 12. And we have the area, 72 inches squared, but we don't have the base. So we have the area, we have the height, we need the base. And so let's write our formula for the area of a triangle. That's how we're going to start all these, right? The formula. And plug in what we have. We have the area, 72 inches squared. We don't have the base, so we'll keep that B. We do have the height, that's 12 inches. So let's write our 12 here. And there's several ways to take care of this half here. I could multiply everything by 2. That would get rid of the half, but we can also do half of 12, and that's easier in this situation. So let's do half of 12, which is 6. So we have 6b now. And let's divide both sides by 6. So b equals 72 divided by 6, which is 12 inches. So our base is 12 inches. All right, very good. Let's move on to trapezoids. So I want to find the area of a trapezoid. Let's see, what was that last one? That was example 4. So let's do example 5. And let's remind ourselves what a trapezoid looks like. Let's say we have a trapezoid like this. Remember, with a trapezoid, one pair of sides is parallel to each other. And let's say our trapezoid, we have base 1, and the parallel sides are the bases, is 9 centimeters. And base 2 is 12 centimeters. Remember, the bases are the parallel sides. And we have a height of 3 centimeters. Remember, height has to be perpendicular to the base. So we have our height, and it is, in this case, 3 centimeters. So the formula for the area of a trapezoid is 1/2 height times base sub 1 plus base sub 2. 1/2 height times base sub 1 plus base sub 2. So we have everything we need here. 1/2 height, which is 3 centimeters, times base 1 plus base 2, which is 9 centimeters plus 12 centimeters. So now we have 1/2 times 3 centimeters, and 9 and 12 is 21. And so now there's several ways to do this. We could do 1/2 of 3 and then multiply that times 21 centimeters. We could do 1/2 of 21, multiply that by 3. Or we could do 3 centimeters times 21 centimeters and do 1/2 of that. So let's do that. 3 times 21 is 63 centimeters. And don't forget, it's centimeters times centimeters. That's centimeters squared. And then the final area will equal 1/2 of 63 centimeters, or 31.5 centimeters squared. Let's try rhombuses and kites. So that was trapezoids. Let's try rhombuses and kites. These two have the same formula. Rhombuses and kites have the same formula for area. If I have a rhombus, this would be example 7. Let's say I have my rhombus, and just to remind you, a rhombus is a quadrilateral, a parallelogram with 4 congruent sides. And if I have my rhombus, let's say I already know the area of my rhombus. Let's say my rhombus is 48 centimeters squared. And let's say I know one of the diagonals. Let's say the diagonal, this diagonal, diagonal 1, is 16 centimeters. And they want diagonal 2, which would be this other diagonal here. They want this diagonal, diagonal 2. All right, let's write down our formula for the area of a rhombus and kite. This is the same formula for both figures. Area equals 1/2 diagonal 1 times diagonal 2. Very simple formula. You just need the diagonals. And so let's see, we have the area. Let's plug that in for A. 48 centimeters squared. It equals 1/2. We have diagonal 1. I move that other diagonal. Let's see, it's 16 centimeters, right? Let me get that out of the way. Diagonal 1 is 16 centimeters. So 16 centimeters. And I want diagonal 2. So I'll just put D2 for that. Let's see, 1/2 of 16 centimeters is 8 centimeters. And then if I divide both sides by 8 centimeters, then I know that diagonal 2 is 48 divided by 8, which is 6. Centimeters divided by centimeters squared is just centimeters. So diagonal 2 is 6 centimeters. And let's do our last one, example 8. And example 8 will be about a kite. And so when I draw my kites, I'd like to do the diagonals first. Let's say our diagonals will be these, of course, these green lines here. And remember that diagonals of a kite are perpendicular, so those do form right angles. And let's say it's labeled this way: 40, 12, 9, and 9. Let's see, our area formula for a kite same as for rhombus, 1/2 diagonal 1 times diagonal 2. Let's figure out what our diagonals are here. Let's see, our diagonal 1, let's call that the long one here. This diagonal 1 would be 40 plus 12, or a 52. And diagonal 2 is 9 and 9, which is 18. And so we have our two diagonals now, so we can easily plug this in the formula. Area equals 1/2 diagonal 1, 52, times, let's use a parentheses there, times 18 diagonal 2. And so area equals, and let's do 1/2 of either one, 15 or 52 or 18, but let's do 1/2 of 18. So 1/2 of, oops, we're taking 1/2 of 18. That's going to leave us with 9. And 9 times 52 is 468. 520 minus 52, 468. And we didn't put a unit of measurement here, so we'll just say units squared. Area is always some units squared. And that's it. That's the area of parallelograms, triangles, trapezoids, rhombuses, and kites.